Hello again. Using the same points A and B, this time we look at how to find their reflection coefficient and transmission coefficient. As you know, both of them are complex numbers and can be represented in terms of a magnitude and an angle. And the Smith chart gives you the tools to do both of that. Let's start with point A. You might notice that there are multiple horizontal bars at the bottom of the Smith chart, each of them having a label at the side. Each bar serves a different purpose. In fact, apart from the bottommost bar, the left half and the right half represents different properties. Let's zoom in to the second bar from the bottom. There is a property that is immediately useful to us. At the left is the reflection coefficient for E or I, E for voltage in this case, and I for current. And you can measure the reflection coefficient of any point from the center, as noted here in the bar. And I'll use A as an example. First, you draw a line from the center point of the Smith chart to point A. With this line, I'm effectively using this line as a ruler, and I'll paste it here, anchored on the center point, and rotate it until it reaches the horizontal position. And again, in your perspective, when you use a Smith chart, you would simply measure this using a ruler. And here it looks like the magnitude is a little higher than 0.7. I'll just say 0.71. So here I'll type 0.71. We still need the angle. And to read the angle, you draw a line from the center of the Smith chart past the point A, all the way out of the Smith chart. And if you look at the rings surrounding the Smith chart, one of the rings, the second inner ring, says angle of reflection coefficient in degrees. So scroll to the appropriate spot, read off the second inner ring. You can get such angle, and here it looks like 42, 44, roughly 45 degrees. Let's put that down at 45-degree angle. And as simple as that, you got the magnitude of the reflection coefficient from the bottom bar and the angle from the second inner ring. Next, we look at the transmission coefficient, also for point A. If we look at the bottom bars again, this time let's look at the right legends. The very bottom one says transmission coefficient for E or I, so for voltage or current. And yes, that is what we will use for finding the transmission coefficient magnitude. For this, it indicates that you measure from the origin to the point, and that's what we'll do. We start from the origin at the left side and go to point A. I'll copy this line, and in your case, when you use a paper Smith chart, you would measure the length of that line and then compare it with the appropriate line at the bottom. Drag it down, and there it is. The magnitude of our transmission coefficient is roughly 5.2, 5.4, 5.6, 5.8, 1.58. Let's write that down. 1.58. And for the angle, we again draw a line, this time from the origin, past point A, all the way out of the Smith chart. This time, instead of using the second inner ring, we look at the first inner ring that is labeled angle of transmission coefficient in degrees. So we scroll to the appropriate location, and there we have it in the innermost ring, you can count from the nearest labels, 15, 16, 17, 18, roughly 18.5 degree. So I'll put it in, 18.5 degree. Note that for gamma and tau, the symbol between the magnitude and the angle really should be the angle sign, but I typed the less than sign for convenience. And there we go. We have the transmission coefficient with the magnitude that was acquired by the bottommost line and the angle that was acquired from the innermost ring closest to the Smith chart. I will leave it up to you to find the transmission coefficient and reflection coefficient for point B as practice.